Dear students, Namaste. Let us start the second part of our lecture for the chapter Introduction to QBasic. Today we are going to learn about operators and their hierarchy in detail. Types of operators. Operators are symbols represented by special characters or by keywords that indicate the type of operation QBasic has to perform on a data or on the value of variables. We are going to see three types of operators used in QBasic. First, arithmetic operator, relational operator, and logical operator. Arithmetic operator. Arithmetic operator is a binary operator. In mathematics, a binary operation is a calculation that combines two elements called operands to produce other element called result. Binary operators are present in the form operand 1, operator, operand 2. Example 4 plus 6. Here 4 and 6 are operands and plus is an operator. Arithmetic operators are those which are used to do arithmetic operations on two numeric constants or variables. The common arithmetic operators are given below. Operators add symbol is the plus sign. It adds two numbers as shown in the example a plus b, or we can add 6 plus 4, or it can be a combination of the variables or the numbers. Subtraction. It is used to subtract two numbers. Symbol is the minus sign. Multiplication. It multiplies two numbers. Here, the symbol is not same as that we use in maths. Here, we have to use the asterisk sign, or you can say the star sign. Division. It divides two numbers. Now here, this is the normal division that we usually do. That is a divided by b or 6 divided by 4. We are getting the answer in decimals. Power. That is the caret sign. It is shift 6 in the keyboard. And it is used to calculate value of one number raised to power of other number. Say x to the power y. Here, a to the power b or 6 to the power 4. A to the power b means I am multiplying 2 5 times. Therefore, I have got the answer 32. Similarly, 6 to the power 4 means 6 into 6 into 6 into 6. That is, we are multiplying 6 4 times. The answer is 1296. Basic can also use two other operators for division. That is, one is the integer division. It returns only the whole number value. The symbol is the front slash. Now, if I divide 6 integer division 4, I'll get the answer 1. Similarly, we have the other operator known as the remainder division, that is also known as the mod operator. The symbol is mod. It returns a value only if an integer division cannot divide a number exactly, or if it returns 0 if a value is exactly divisible. For example, 6 mod 4, the answer is 2. Why? Because if you divide 6 by 4, the remainder is 2. Let us see this practically. Here I have written a very simple statements in QBasic. Print 6. This is the, we are going to see the output of as 6 divided by 4. This is a string, or it is a message, you can say, which we will see in the next class in detail. 6 normal division 4. Next print statement consists of 6 front slash 4 means 6 integer division 4. Then the last one is 6 mod 4. It means it is going to give me the remainder. So let me run it. Now you can see the output. 6 divided by 4, that is a normal division, the output is 1.5. 6 integer division 4, the output is 1. And 6 mod 4, the output is 2. So 2 is the remainder, 1 is the integer division, that is the quotient having no decimal value, and the 6 divided by 4, that is a normal division, is 1.5. I hope you have understood the different type of division which we can do in QBasic. Relational operators. These are binary operators. Relational operators are those which are used to compare two numeric constants or variables. That is, they take two numbers or variables or constants, compare them, and the result is either true, that is non-zero, or false, that is zero. The common relation operators are the symbols, uses, and examples are followed. I'm sure all of you are aware of the relation operators which is shown here. First is operator is equal to, the symbol is the equal that you use, and it checks whether the two numbers or two variables are equal or not. Now here example A is equal to B. I am taking A is equal to 2 and B is equal to 5. If I compare for equality, this is false. So I will get the output as false, that is 0. Then less than, the symbol all of you know, and it checks if one number is less than the other number, that is A less than B. It is true. Greater than, it checks whether the one number is greater than the other number, that is A greater than B, so the output is false. Less than equal to, the output is true. Greater than equal to, the output is false. And this symbol not equal to the new one, remember it is the both less than and greater than sign. First less than, then greater than sign. It checks if the two numbers are not equal to each other, that is A not equal to B. This is true. So we are going to see it practically. So in this program, I have taken a variable A which I initialized to 2, and I have taken variable B which has the value 5. Now the simple statement as I have discussed in for the relation operator. So print A equal to B. I have written this, the figure which are the one which are seeing in the yellow color are the message which are going to see on the screen, and with the white color it is going to be evaluated or processed, and you are going to see the output either 0 or non-zero value. If it is 0, it is false. If it is non-zero, it will be true. So let us see the output. I am going to run the particular program. Click on run, or you can press F5 directly and start. So the output here is A equal to B. The output is 0, that is false. A is less than B. The output is -1, that is it is true. Since it is not 0, therefore it is true. A greater than B, that is 2 is greater than B, that is 5. No, so it is false. Is A is less than equal to 5? Is 2 is less than or equal to 5? Yes, so I am getting a non-zero value. Similarly, A greater than equal to B, the output is 0, and A not equal to B, we are getting again the output as true. Let me change the value a little bit and see again the outputs. I'm just reversing the values. Now you're going to see the output. So let me run it. So here you can see again we are going to get the values in 0 and non-zero. The value which are 0 are false, and that is the output is false, and which are non-zero the output is true. I'm sure you have understood the relational operators. Logical operators. Logical operators combine two or more relational expressions to evaluate a single value as true, that is non-zero, or false, zero. The result of evaluation is used to make decision about the program flow. The commonly used logical operators in QBasic are AND, OR, and NOT. So the both logical operators and the relational operators are usually used to make decision. So the logical operators, AND operator, the symbol is A and D, and it used when both the conditions to be checked must be true. Or here it is going to give me the output true when either one or the other or both the conditions are true. Not here, not it neither or the conditions must be true. Now here the not is a unary operator. Now we are going to see in detail little bit about this logical operators. Here I am going to show you the truth table for the logical operators. I am taking two operands A and B. The A and B are the relational expressions. They are either returning me true or false. Since there are two operands, so and each having two possible outcomes, so in total there will be four possible outcomes. So the outcomes are arranged in the form of true true, true false, false true, and false false. Now let us see the first, the not operator, not B. Not is a unary operator. That means it takes only one operand. That is, now here in example I am taking B. So the B, the first is true. Therefore, once I use the not B, then it will become false. Once if the B is false, after applying not B, it is going to give me the output as true. So it is negating the particular output. Next is A and B. Here I am using the AND operator, A and D, AND. The AND operator returns true when all results returned from individual relational expressions are true. Otherwise, it returns false. See in the truth table, the first line, that is TT, therefore the output is T, that is true, and the remaining are false. OR operator A or B. The OR operator returns true if any one of the relational expression is true. If all the relational expression returns false, then only the combined result returned by OR operator will be false. Can you think of an example of and or where we are going to use? Okay, let us check the divisibility rules. Let us see the divisibility rule by 6. The statement is if a number is divisible by 2 and 3 both, then it is divisible by 6 also. So what it says, listen the particular statement carefully. If a number is divisible by 2 and 3, then it is divisible by 6 also. So in this statement, I can use clearly the AND operator to find whether a given number is divisible by 6 or not. If I'm getting the output, that is if it is divisible, that means if I'm getting the remainder 0, then we will say that yeah, it is divisible. So I can write if number divide by 2, give me remainder 0, and number divide by 2, divide by 3, give me remainder 0, then it is divisible by 6. Similarly, for the OR operator, let us check the divisibility by 5. It says a number which is either 0 or 5 in its ones place is divisible by 5. So, again listen the statement carefully. It says a number which is either 0 or 5 in its units place is divisible by 5. That means whenever you are going to take some decision or in any statement, you are using the statement like this where you are using either or. In that case, we are going to use the OR operator. And the statement where you are saying the AND, in that case, we are going to use the AND operator. With the example of this logical operator, we are going to see practically in the next class when we are going to do programming. An expression is a combination of operators, constants, and variables that is evaluated to get a result. The result of the expression is either numeric data or logical value that is true or false and can be stored in a variable. For example, the following are expressions in QBasic. Within bracket a plus b greater than c. Next, u into t plus 0.5 into a into t to the power 2. When a normal calculation is made, QBasic works from left to right, but it does certain calculations based on hierarchy of operators. Hierarchy of operations. Expression may contain more than one operator. While evaluating such expressions, a hierarchy is followed. The hierarchy followed is same as the BODMAS rule in the mathematics. In QBasic, following BODMAS rule is followed. B stands for bracket, O stands for order or power or the exponentiation, D is division, that is your normal division, M is multiplication, A is addition, and S is subtraction. Okay, remember, when parenthesis is used, it changes the order of hierarchy. The operators inside the parenthesis are evaluated first. Again, those operators will be evaluated on the basis of their hierarchy as given earlier. Algebraic expressions cannot be used directly in programming. It must be converted into QBasic expressions as shown below. Algebraic expression A is equal to L into B. This is our normal algebraic expression. For the QBasic expression, I am going to write A is equal to L asterisk or the star B. Similarly, the algebraic expression P is equal to, this parameter is equal to L plus B, but in basic we have to write P is equal to 2 into L plus B because computer will not understand that there will be multiplication between 2 and L plus B. So in this way we have to convert the algebraic expression into QBasic expression. Now we are going to see some examples of evaluation of expressions. Now this is the example which I have taken from the book. Here it says find the value of 23 plus 8 divided by 5 minus 1 into 3 to the power 2. Now if you see here, the bracket is there. So we have to evaluate the bracket first. So after evaluation of bracket, I am getting the expression as shown 23 plus 8 divided by 4, that is the 5 minus 1 is 4 into 3 to the power 2. Next comes the power in the hierarchy. So I will solve this first and I am getting 9. That is 70 plus 8 divided by 4 into 9. Then division. So I am getting 8 divided by 4 I have to do. So the answer is 2. So it is 23 plus 2 into 9. Now I have to do multiplication. That is 2 into 9. That is 18. So I will get next step 23 plus 18. After that I have to plus. So I am getting the answer 41. So we have to be very strict while performing the evaluation of a particular expression. We have to follow the hierarchy rule, that is the Bodmas rule. Otherwise, we are going to get the wrong result or the answer. In this example, it is 11 into 2 plus 8 into 4 minus 7. Now here, multiplication is coming 2 times. So in this case, we have to remember that QBasic always evaluate the expression from left to right. So first, we have to see in the left hand side, the multiplication sign is there. We have to evaluate that particular expression first, that is 11 into 2. So I'm getting 22 plus 8 into 4 minus 7. So again multiplication is there, so it is of higher hierarchy, so I will do that first. So 8 into 4 I will get 32. Then after that, the expression we are getting is 22 plus 32 minus 7. Here plus have the more hierarchy, so I am getting the answer 54. 54 minus 7, that is 47. In the next example, we have 5 plus 18 divided by 3 to the power 2 into 2 minus 1. According to Bodmas, here we don't have a bracket, but we have the power or the exponentiation operator, which is of higher hierarchy. So we are going to solve that first. So 3 to the power 2, that is 3 into 3, that is 9. So the next expression comes to be 5 plus 18 divided by 9 into 2 minus 1. So division comes first. So 18 divided by 9. So the answer is 2. In the next one, multiplication have the higher hierarchy. So we will solve the multiplication or evaluate the multiplication first. It is 2 into 2, 4. Then 5 plus 4 minus 1 will do addition, that is 9. Then minus 1, that is 8. In the next example, we have the bracket. So we have to solve the bracket first. So I am solving here 3 minus 1. So I am getting the answer 2. In the next expression, we have the power sign which has the highest priority. So I am going to do that. That is to the power 4. That is 2 into 2 into 2 into 2. That is 2 4 times. So it comes to be 16. Don't do 2 into 4. It is 2 into 2 into 2 into 2. That is I am multiplying 2 4 times. So it is 16. Next, in hierarchy in this expression, third one is division. So I will divide 30 divided by 16. The answer is 2. Next is multiplication. So I will do 2 into 2, that is 4. After that, 7 plus 4, that is 11. I hope you have understood how to solve the expression and to get the result with the help of QBasic, or how the QBasic internally solve the particular expression that we give. So dear students, I hope you enjoyed the class and understood. With this, we came to the end of this chapter, Introduction to QBasic. Go through the concept again, revise it, because in next class we are going to do the programming in QBasic, and in that we are going to use these concepts for writing the program. So dear students, thanks for patience hearing. Have a nice time. Bye. See you in the next class.